Okay, so here is a definition that you want to commit to memory or to write down on a cheat sheet if they allow you. This fact right here. This is going to show us how to go from a Riemann sum to a integral expression. So that's a fact that's in your textbooks. It should be somewhere in there. Let's use that to convert this Riemann into an integral. So maybe we can go like this. And so this here matches with that. And we're going to go from here to there. So I know I'm going to need an integral. And I don't know a or b or the function f of x. But I do know that it's going to be capped off with a dx. So that's what I do know. We just got to find a, b, the function, copy and paste it there, and we're good. Now, maybe we can accomplish this by sort of a comparison of structure. Compare this with this. Limit, Riemann sum. There's nothing here that we learn nothing from this part there. Really look there and look there. If you compare the structure of these things, that's going to tell us what's going on. So let's make some comparisons. We have a function f of x and then a delta x. Really, all of this here to there, that looks like the function. And this part here, that looks like the delta x, right? The f of x is this, the delta x is there. Now, even more than that, the x sub I is the quantity that's being plugged into your function. So if this is your function here, it really does look like the stuff being inputted is that there. So that kind of plays the role of x sub I. So what we can do is we can create some assignments. We can say, hey, that there, you have to equal x sub I. So we can say x sub I equals 1 plus 2 over n times I. Also, hey, 2 over n, you have to equal delta x. So delta x has to equal 2 over n. But what we can do is we can create some further substitutions. For instance, instead of x sub I, that's the definition of x sub I. So this here can go there. And similarly, instead of delta x, which is that, this here can go there. So let's make those changes. So this is a plus delta x times I equals 1 plus 2 over n times I. And similarly, delta x becomes b minus a over n equals 2 over n. So look at this equation there. Notice that the ends in the bottom can knock out. And if they do, that tells you that b minus a equals 2. How about over here? Compare the left with the right. So a, it seems like a goes with that, and this goes with that. Because remember that we said that 2 over n is delta x. So that 2 over n, that can also become delta x. And I'm actually glad I did that, because now you can clearly see that the delta xi knocks out. And so we've seen now, we've concluded that a is 1. And if you plug 1 for a there, we can quickly find that b is 3. And now we can go back to the main problem, because we wanted to write it like this. So we know our limits of integration. A is 1 and b is 3. All that's left to fill in is your function f. But remember, our function was this here. But that's the very special input x sub I. But generally speaking, before it was x sub I, it was just a general input called x. So really, the function there that you see, it's really just 2x plus 5. And so I propose that really our f of x function is just 2x plus 5 in parentheses. So this here, I propose, is the result.